Okay, hi, my name's Asha,
My name's Deven.
and this is our presentation for the Maker Faire. Okay, so our project is a sugar growth lab. It contains elements of mathematics and science to produce a delicious result. We made what is known as rock candies by growing our sugar over the span of 6 days, and over the course of those 6 days, we measured how much the sugar grew per day. At the end of the 6 days, we were left with these beautiful sugar crystals, and our project was like in a lab format, so kind of reminiscent of something you would do in chemistry or biology, for example. And then we just have some photos of not our project, but what projects will look like.
So in preparing for our project, we developed a relatively simple materials list. So we needed sugar and water to make the crystals, and we used a notebook and writing utensil to keep track of the growth of the crystals. And we used a scale to measure the crystals, and then the wooden dowels to actually have the sugar crystals form on.
And then we have a photo just of the dowels that we purchased off Amazon and what a sugar molecule looks like. Okay, so our process. So before we even get into like the actual building process, I guess we'll talk a little bit about the research that went into our Maker Faire. And so when we were generating ideas, we wanted to do something that was related to science, and we wanted to do something preferably edible. And our original idea was to look at sugar growth and crystallization on cookies. But as we continued with our process, we realized that wasn't going to be able to be a tangible thing, just because of like time constraints and the facts that cookies get stale and spoil before the Maker Faire. So we decided to just stick to this to be easier. So the actual process, we measured our ingredients. We used the scale to weigh the sugar initially, and it's a 3-to-1 ratio of sugar to water. 3 cups sugar for every 1 cup of water. We dissolved the sugar in a pan. We heated the water in a pot and gradually added the sugar, stirring with the spoon until it was fully dissolved, until no more sugar could be added until it reached the highest point of concentration. And we continued to add sugar until it didn't dissolve. So that's a supersaturated solution. And then we allowed this solution to cool, and we added food coloring here, and then we transferred it into our containers where the actual crystallization growth took place. We prepared our wooden dowels, so we dipped them in water and rolled them in sugar. We let that dry, and then we added that to the empty water bottle before adding the solution in to help the crystal form.
And then we suspended the dowels, so we placed the dowels into the solution so they didn't touch the sides or the bottom. And then we recorded our observations to see how the growth progressed and to track the crystal formation. And then we waited for our crystals to grow. So we did a 6-day period of growth where the crystals were able to grow from small amount to larger amount, which you'll see in the data table on the next slide. And then we removed and dried. So we took out the wooden dowels and let the crystals dry before presenting them.
And then this is a representation of our data. So we took measurements for 5 different candies, I guess you would say, and obviously all the starting weight was 0 grams, and all the data in our graphs that you saw on our presentation board at the Maker Faire is based off of the average data. And the dowel weighed 1 gram, so in all of our data here we've accounted for that by subtracting 1 gram.
So we learned the science behind a supersaturated solution and how sugar crystals form after being in this state, and we also applied our knowledge of mathematical graphs such as derivatives and exponential graphs to a real-life situation, the crystal growth. And this project taught us a blend of science concepts and mathematical concepts by, doing an experiment involving the growth of sugar.
And then what we would do differently. I think there's a lot of things we could do differently if we were to redo this experiment. Instead of just using dowels, we could try using strings to give the crystals more surface area to grow on. And we also noticed that letting the solution cool too fast might have affected the crystal formation. So next time we'll let it cool gradually for a few more hours than what we did this time. And to keep dust out and for slow evaporation, we'll cover the container with a paper towel. And that's a material where there's still enough space for water to be able to evaporate. We learned that heating the solution to the right temperature, around 230 degrees Fahrenheit, can help the sugar dissolve properly without caramelization, and most importantly, we'll make sure not to move the container while the crystals are forming, since every small vibration can disrupt growth. And by making these changes, we hope to grow bigger, better sugar crystals next time. One final thing that we would do differently would be more color variety, because we only added red food coloring. And so in the future, to have a more, I guess, colorful presentation using different food colorings.
Yeah, not as boring.
And then this is a photo of our presentation, of our project, what it ended up looking like. I would say it's a success. Thank you for listening.